So we are working on the second day of 4-1. My plans right now, and I'll let you know for sure next week, is to do 4-1 and 4-2 and to do a test on them. Last semester we were too much stuff in one, and I never got to really see if you knew it. 4-2 is involved, okay? And it takes some time, but I want to make sure at the depth at which I want to take you into 4-2 because we really dive into it in pre-calc. So we'll see. We may and we may not. The chapter is really short anyway. There's only 5 sections in it anyway, so we'll see. Okay, so I give you, this is the reciprocal function, 1 over x, and it says graph it and state the domain and range. Well, any equation I give you and I ask you to graph, what could you do to graph it? Any equation, no matter what it is. Any equation I write out there, how could you graph it? Even if you didn't know what it's supposed to look like.
Plug in numbers.
Plug in numbers and get out numbers, yes?
Okay.
It's the basic way I could do that, and that's what we're going to do here. And I don't have to know exactly what an equation looks like.
You're at Rutherford there.
Yes?
I need to have him come to the office, please.
Okay.
Thank you.
I do not have to know what a graph looks like in order to graph. It's helpful if I know the parent behavior and I know the movements, like we did quadratic and what absolute value that way. And we will get to that with this too. But right now we don't. So let's see, I'm just gonna make a little key table. And I got x and f of x. What does f of x mean when I put f of x? That's the same as y. It's the same as y, right?
Yeah.
F of x means I plugged x into the function. Okay, so we're going to do, how about -5, -3, -1, 0, 1, 3, 5. And I just plug them in, right? So if I plug in -5, I get what?
-1 over 5.
-1 over 5. So 1/5, -1/5. And when I plug in -3, -1 over 3. -1, -1. 0?
0, 1, negative. I don't know. Oh, it'd just be 1 over 0.
You have 1 over 0.
Ah.
So that's just 0, isn't it?
That would just be 0.
Can I divide by 0?
No.
No.
So that's just 0.
It's undefined.
Oh.
Okay, I cannot, you guys know why you can't divide by 0.
Why?
Okay, here's a pin. Okay. Can I divide it in half?
Yeah.
Yeah.
Yeah. Can I divide it in 8s?
Yeah.
Can I divide it in no parts?
No.
Because I still have what? I still have 1, don't I?
Yeah.
So can I make this no parts?
No.
Not until I know math, and I don't know that yet. Okay, so 1, 1, 3,
1/3, 1/5.
and 1/5. Okay, so as my numbers get smaller, my y's get smaller, yeah? Closer and closer to 0. They ever gonna get 0? Is there anything I ever could plug in there and get 0? No, I get something really, really close to 0, right? But could I ever get 0? No. What if I plug in a half? If I plug in a half, it'd be 1 divided by a half, so it'd be times 2, right? So it'd be 2.
Yeah.
And if I plug in like an 8, it'd be 1 over an 8, which would be 8. So I'm still, this 0 right here, this space right here, that's going to like infinity, isn't it? Okay? And would that happen the same way here?
Yeah.
It'd go to negative infinity, wouldn't it? Okay. So, well, let's graph what we have. And we got all that for plugging in 7 numbers. And thinking about what numbers do when I plug them in. It's called number sense. It's a good thing to have. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2. Okay, so at 5, it's a fifth, right? Negative a fifth. Yeah, whatever. You got it. And then a third. And then 1. And we talked about what is this going to do? It's going to do what?
Start going down.
It's going to shoot to negative infinity. Is it ever going to touch that y-axis?
No.
No. Going to get really close to it, but is it ever going to touch it?
No.
Nope. Is it ever going to touch the x-axis?
No.
No. It's going to move closer and closer, right? But it's never going to touch it. It's never going to cross it, is it?
No.
Okay. So this one, what's it going to look like?
Just above that.
It's going to do this, isn't it? That's a horrible curve. I can't see through my hand. Okay, it's going to look like that, right? It's getting close to the x-axis, yes. But is it ever going to be y is 0?
Yep.
No. Is it ever going to get to x is 0?
No.
No, it's not. So we just graphed it and we had no clue what that looked like before, did it? Okay, so what's the domain?
All real numbers.
It is?
Except for 0.
Except for 0. So x such that x cannot equal 0. Today is the last day I will personally use set notation. I will be using set notation. I will not be using interval notation after today. If you would like to use interval notation, which is the second one, you're more than welcome, but you better do it right. So that means the U has to be there. Okay? That means union, and that means and. I have the union of things that combines them, yes? And parentheses mean non-included. So if we put brackets, are you wrong? Yes, because it can't include 0. So today is the last day I personally will use interval notation for domain and range. The reason for that is we will do interval analysis where we cut things into intervals, and I personally do not like to have interval notation on a domain and then interval notation when I'm doing something else. Because then my brain wants to do what with the two things?
Combined.
Combine them, and they're two separate things.
Too many big words.
Okay? So here is my domain, and what is my range?
Negative infinity.
All real numbers except for
Y
0.
such that.
Y such that y can equal or not equal.
Y is not equal to 0. Now, I'm not saying the textbook will not use interval notation, like when you do the online stuff. So I've always said you have to know how to use both, right? Always said that. But I just don't write it because my brain wants to smush them together. So I've got to keep them separate, but I don't use it very often. The other reason for this is I can have infinitely many things that x cannot be. And you're going to learn in a minute what that word actually is. I can have infinitely many of those. So if I have 6 things that x cannot be, I'm taking the x-axis and cutting it 6 times. How many pieces do I have then? 7. You would have to make 7 of these intervals. If you do it set notation, you just say x cannot equal, comma, 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 from least to greatest. That's the worst part of that. I don't want to do 7 intervals. Do you want to do 7 intervals? You personally are not going to graph something that has 7 intervals, but someday some of you may, but not in here. Okay, so this is a graph. This is the graph of what we just did. Okay, so I put the book graph so you could see it. You don't have to redraw it or anything. You might want to add to it. They've got these dotted lines at y equals 0 and x equals 0. See that? Okay. They're imaginary lines, and they will be on your graphs as well. They're called asymptotes. That's what those things are. An asymptote is a line on a graph that the curve actually approaches, it never touches, and it never crosses. Isn't that what we discussed about these curves? They are never going to touch 0, y equals 0. They're never going to touch y equals 0, are they? Or are they going to get really, really, really close? Yep. Are they ever going to touch x equals 0?
No.
Nope. But they're going to get really, really close. So, y equals 0. Y equals 0 is right here, yes?
Yes.
And that is a what kind of a line? No. What kind of a line is a
Imaginary.
Horizontal.
horizontal?
A straight
Okay.
line.
Yes. Woo. Okay. Y equals 0 is the horizontal asymptote, and we will abbreviate it, guess what? It's rocket science.
AK.
HA, or what?
Rocket.
Horizontal asymptote. If you would like to write out horizontal asymptote, you're more than welcome, but I don't want to do that. So we showed ourselves, there was nothing I could plug into 1 over x and get out 0, was there? There's nothing. I'm going to get really close to there, but I'm not going to get it to 0. Now, we have a vertical line at x equals 0. That is the equation of a vertical line, isn't it? X equals. So at x equals 0
Vertical.
is our vertical asymptote, and what are we going to use for it?
A and VA.
Please tell me you did.
Okay. So we're going to use vertical asymptote. Now, we need to talk about this, guys. Equations, when it says what is the equation of the asymptote, this is an equation of a vertical line, correct?
Yeah.
Yes. Okay. We need to understand that vertical lines are x equals something because they never touch the y-axis unless it is 0, correct? Vertical lines only touch what axis? The x-axis. That's why it is x equals. Now the exception is if it's x equals 0, because it's 0 for both of them. And horizontal lines is they are y equals because they only touch what axis? The y-axis. Now, so when you are asked to state an asymptote, it says state the asymptote. You state both horizontal and vertical every time. If it says state the asymptotes, they shouldn't have to tell you to state horizontal, state vertical. Got it? The other thing is you always will state them as an equation. So when it says state the equation of the asymptote, well, what is the equation? X equals 0 for the vertical,
Oh, yeah.
and y equals 0 for the horizontal. You never say, when I say, what is the horizontal asymptote? You never say 6, ever. It's y equals 6. Because if I ask for horizontal, it is a horizontal line, and they have the equation of y equals. Every time.
So how do you know what that number, how do you know what the number is? Like, y equals?
Oh, well, no, but, okay, right now we're talking about this right here, yes? The parent function. That is the parent function we're talking about. Remember when we did the parent function of a parabola? Yes? And we had x minus h squared plus k? We're going to have the same thing happen here. I told you I would teach you h and k would always do the same thing no matter what I taught you equation, and it's still going to apply. Okay, so you'll have to know moving left and right, up or down, and that will tell you. The other thing is, as we get more involved past today, they will give you nice things like 2x squared minus 7x over x squared minus 4x plus whatever. Okay? How did we get the vertical asymptote? We can't divide by what? 0. So wouldn't we set all this equal to 0? Yeah. So you would factor, hence topic 3, right?
No.
Factor, solve for 0, and that would tell me my domain restrictions or my vertical asymptotes. And then we will have another way for horizontal as we get more complex. But for today, I'm going to show you the H and K, and that's what you're going to use. Okay? So the H and K is when you're very basic, but then after that you have math that you have to do. Okay, so what's this graph going to do?
Probably the same.
I changed
thing.
1 to 10, yeah?
Yeah.
Okay, so we're going to, again, does anybody have a guess what the shape is going to be?
The same thing.
It's going to look like the same thing, right?
Yeah.
But what's going to happen? So they wanted what? Like -10, -5, -2, -1, 0, 1, 2, 5, 10. Why did I choose those numbers?
Because they're all divisible by 10. Well, by
They all go into 10.
They're factors of 10.
They're all, yeah, factors of 10. So, and I could go on, right? I could do 200, correct?
For some reason.
Fractions aren't bad. They happen. We just had fractions on the last one, right? But once we know what this is going to do, can't we just continue it? Yep. Asymptotes are like magnets, guys. they draw a graph towards it, and it will keep shooting either to negative infinity or positive infinity. It doesn't change once it goes out, and it's always end behavior. It can do funny stuff in the middle. Okay, negative 10, what do I get? And then,
Negative 2,
-2,
negative 5, negative 10. Undefined.
undefined. Why is it undefined?
Because
Can't divide by
it's
zero.
Can't
like
divide by 0. We can't poof it away.
10,
5,
5, 2.
1.
Okay.
So they pretty much just stay the same numbers that are on.
Well, right now. Right now.
For this one.
Okay, I will not give you graph paper because we are making sketches. And if I give you graph paper, you get to do a chart and find actual points, and they better be exact. Do you want that?
No.
No. We are doing sketches. Okay? And after just these basic ones, you won't be doing this either. We will be finding certain points, and we will be connecting the dots. Make sense? Okay, so negative 10 is negative 1, right?
Yeah.
And negative 5 is negative 2. And then negative 1 is negative 10. Wait, I have 2, I gotta go 5, right? And then 10. Now, if I had the same scale on both of them, what would you notice about this one? Does it change at a quicker rate? Yeah. It's going to change at a much quicker rate. The other thing is, I just did this wrong. If I continued this, my line would go down like this, wouldn't it? It needs to be not dramatically up, but it at least needs to be straight. Does that make sense? Okay, so this one, what's it going to do?
It's gotta go the other way.
It's gonna go the other
Flip
way.
it.
It's going to go the same thing, right?
1, 10, 2, 5, 5, 10.
One, I'm going two. I'm like off. Am I off? 2, 5. Oh, 5, 2. I was switching them in my brain. And then all I do is what?
Connect the dot.
Now, I don't care if you put arrows on both. You have to have arrows on the positive and negative x-axis. Have to have those. Okay? Now, you will see me do my graph, and I typically just go like this, and I put it at the end, and I go from here, and I put it at the end. Because we go from left to right, correct? Do we know that it extends both ways?
Yeah.
Yes. I don't care. Okay, domain.
Domain is x such that x does not equal 0.
This one didn't change at all. I did not move this thing anywhere. What would have changed that? If I moved it what direction? If I moved it up, would that change it? No.
You have to move it like.
I have to move it left or right. To change the domain, I would have to move this graph left or right, wouldn't I? Okay. What is my range?
Y such that y non equal 0.
Okay. Now, what would have to move? What would have to change to move that? Up or down? What variable would move it left or right? H. What variable would move it? K. The same as before. Whoa.
I did not remember.
Look it up.
Oh, vertical asymptote
What the?
Asymptote is 0.
is
That's
x equals 0. Horizontal asymptote,
y equals 0.
y equals 0. So if I moved my domain, would my vertical asymptote change? Yeah, that's what I'm actually moving. When we had a parabola, we moved the vertex, right? We moved that anchor point, the vertex. Well, here, do I have a vertex? No, I have that origin 0 to 0. I'm moving that. Okay. So,
How would you know if it's like a different? Like the asymptote.
Oh.
Okay, so review time. So parabola x minus h squared plus k, right? Absolute value x minus h plus k, right? Cubic x minus h cubed plus k. Could I do that with any of them? Yeah. So what do you think this one is?
X plus k. X plus h.
Why would it change to plus h when they've all been minus h? Would that change?
No.
No?
I think the outside
That was the outside change? No.
The
So this is what I have for you. What would the general form be?
There's a fraction.
It'd be y equals
1 over x minus h plus k.
woo woo.
Wow. I'm too good.
Put something on your face.
It's hurting my ears, so I'm just
Oh,
like
is
trying
it
to
too
hold
tight?
it. Yes.
So did the h is still grouped with the x, correct?
no.
Just like before. And the k is outside the function. Because outside of my function is going to adjust only my y, isn't it? Inside my function is going to affect my x. Because my function is right here. Yes? Do you guys see that function right there?
Yeah.
Okay, so anything I do inside the function affects the x. After I perform the x, I have a y. And so if it's out of the function, it's affecting the y. So what is the special thing I need to remember about the h?
It's always paired with the X.
It's always opposite because the formula says what?
minus.
Negative. It says minus, right? So in this one, my h is what?
Negative 3. 3.
H is 3, not negative 3. Where's the negative come from? The formula, right? It didn't come from the h, did it?
No.
What is my k? 2.
2.
So this is going to move me what? Left or right?
Right.
Right 3. You already took the opposite to get there. Once you write h equals, you've already done the opposite. Because if you do the opposite twice, what did you just do?
Then you went back.
The same.
You went back to that you didn't do anything, right? Okay, so what's this k do?
Up to.
Up 2. Okay, so now you don't have to do what I'm going to do first. Originally, we had zeros, and see how these are slanted? When you have asymptotes that lie on the axis, you just kind of slant them, okay? So originally, this is what I had, right? Well, that's just basically what you have to do because there's really no other good way to do it. And I should have made those dotted. Shoot. Okay, that was my original equation, yes?
Uh-huh.
I had my horizontal asymptote at y equals 0 and my vertical asymptote at what? X equals 0? But what did I do with this now?
You moved
I moved my vertical asymptote where?
3.
To 3.
Right.
So 1, 2, 3. And you will put the asymptotes on your graph with dotted lines because they're imaginary. Do not draw solid asymptote lines. Why?
Because that will mess it all up.
Well, they're not real. Are they like,
No.
it's like an imaginary number. Do we plot an imaginary number? No.
You just put
Just put eyes. But here we have to show it. So I know that you know where to go. And then what happened to my
Go up to.
horizontal asymptote? It went up 2. So what is happening? What happened to my graph?
It just shifts
It went
over.
over and
Up.
up. So it's where?
Right there.
There and
Right there.
right there.
Oh, I see what you've done.
Whoa.
You guys see what happened?
That's strange.
That's pretty cool.
Okay. Just like we took a parabola. Didn't we take a parabola and move it left 4 up 6? And then we'd reflect it sometimes?
Yeah.
Ooh, we're gonna do that too.
Don't you
Not
do
today. Not today. Okay, we are gonna do a lot of different things with this, and it's not gonna be easy. You're not gonna just look at it and go, oh, there's the H, there's the K. We're gonna have math that we do to figure it out. Because honestly, when I got this problem, I got common denominators and started to do the whole math process. Because that's just what I do. I don't look for H and K. I just don't. But it's there. And I can use it. So now, what is my domain?
Domain is X, the
What can X be now?
Three. It can't be 3 or
3.
2.
X can't be 3. Now, I want to ask you a question. Mathematically, why cannot X be 3?
because it does not
I
have,
thought it had
Three is imaginary number.
Mathematically, that means you have to look at the equation.
because
Why cannot
minus
X?
3.
Why can't X be 3?
H is 3.
And what does that have to do with it?
The H is in the equation. Well,
You're right, but why?
It's X minus H.
It's
So
X
they're
minus
opposites.
H. It'd be 3 minus 3, and you can't divide by
0.
0. So if I just set the denominator equal to 0 every time, would it tell me my domain and my vertical asymptote? Yes. Okay, so what is my vertical asymptote?
vertical asymptote is 3.
Not
X
3. X
equals
equals
I
3.
knew that.
Okay?
Sorry.
Now I did misspeak because you can grab all of your vertical asymptotes out of your domain, but not all of your domain all the time will be vertical asymptotes. It's like the square and a rectangle. Squares are always rectangles, rectangles are not always squares. So when I'm looking for vertical asymptotes, if I write something that wasn't in my domain, I'm wrong. But sometimes my domain has extra stuff that my vertical asymptotes don't have. And I'll show you how to get that. But range. Say that again. Is that what you said?
Please.
Okay. The domain will have every possible vertical asymptote. Okay? I said possible. So sometimes there's something in the domain that's not a vertical asymptote, and you'll see mathematically why that is later on. But so I was just, when I said I said your domain is your vertical asymptote, that's not correct. Because not everything in your domain, excluded in your domain, is always a vertical asymptote. Okay, so,
It's not equal to 2.
to what?
2.
To 2. Because I took that 0 and moved it where?
Oh, 2.
Up 2. So y is not equal to,
The horizontal.
and the horizontal,
is Y.
Y equals 2.
Because. That is not it.
well, that's just because it moved it up 2. Mathematically, there's not a reason why that is.
Nancy
Yeah.
Bond.
Okay, that is the last of our examples. Your assignment is posted. Can you answer that, or somebody? The assignment